Hello, Coach Holmes here, and today we're going to be talking about inductive reasoning. Okay, so first off, what is a conjecture and what is inductive reasoning? So a conjecture is an unproven statement based upon observation. Okay, so basically, if you see, for example, if you see a statement that's not been proven yet, a statement that hasn't been proven, but it's based off of the observation. So if you observe the statement and it hasn't been proven, that's a conjecture, okay? It's just a statement that hasn't been proven yet. Now, inductive reasoning is a process of finding a pattern, patterns and to write a conjecture based upon specific cases. Okay? So basically, if you see a pattern going on, basically inductive reasoning is seeing a pattern and being able to make a case for it. Being able to write a statement about it, about what the pattern is going by. So, obviously, when it comes to finding the pattern's not on your notes. So go ahead and pause this video so that way you can draw this out real quick. There's just two patterns I want you to draw out. So go ahead and pause this video so that way you can draw the pattern out in your notes real quick. Okay? Now, so I got two patterns here. So if you notice this first pattern right here, I got a bunch of triangles here, but I got a dot in a different direction. So I got a dot in the top, bottom right, bottom left, top, bottom right. So noticing the pattern, so if I'm looking at this pattern right here, I know it's going to be a triangle, but the dot right here seems to be going clockwise. So if it's clockwise from here, then the next one's going to be end up right there in the bottom left. And if I keep going, I can do as such. So really it's just noticing, so really my inductive reasoning is telling me that the dot is just going clockwise amongst the three corners of the triangle. Now the second pattern right here, I got three circles. I got 1 1/2, 1 1/4, and 1 6. So obviously, just thinking about it, and if you think 1 4th, 1 6, so it's going to be 1 4th, 1 1/2, 1 4th, 1 6. So I'm thinking, well, if the denominator is kind of going by 2 technically, that's one way to look at it. It's going by 2 each time, or yeah, it's going by 2 each time. The denominator is, I would think 1/8 will be the next one. So if I draw it out, I would say the next one will look almost like that. And I hope you all thought the same thing. Okay? So that's what inductive reasoning is. It's being able to think through the pattern even though it hasn't been proven yet. Because we can keep on going and be like 1/10, 1/12, 1/14, and so on and so forth. But it's kind of hard to draw those, honestly. But that's what inductive reasoning is being able to think through the pattern. It's being able to think through the pattern of what's going on. Now, there's another part about patterns that can be broken. There are some things that can be broken, some statements. And it's called counterexamples. Counterexamples are a case that makes the statement false. Okay? It's just one case. One primary example, one good example to make the case false. And that's a counterexample. It's almost like if you say like Odell Beckham Jr. is the best football player of all time. You can actually give a counterexample and say, well, Jerry Rice has better numbers, or Randy Moss has better games, or Terrell Owens has a better career, and stuff like that. You can give counterexamples and say, well, you may say that, but here's an example that contradicts it. Okay? And you just have to have one sample. You just have to have one case in order to prove the entire statement to be false. You just have to have one case. Now, all dogs has black fur. Okay? So find a counterexample. Well, not all dogs have black fur. One primary example would be golden retrievers. And I know it's probably spelled wrong, but you get what I'm saying. Golden retrievers do not have black fur. They're more like a yellow golden color. Okay? Also, there's brown fur. You can also say that. Some dogs have brown fur. Some dogs have white fur, white fur, or anything else. Those are just examples. You don't have to have so many examples. You just have to have one. Now, next is the sum of two numbers is always equal to or greater than each number. So here's the example, what it's talking about. So say we have 3 plus 4 equals 7. That's true, right? 3 plus 4 does equal to 7. The sum, which is 7, is greater than both 3 and 4. Okay? Now, can we find a counterexample to that? Well, initially, no. If you're only looking at positive numbers. However, if we look at negative numbers, so for example, negative 5 plus 2 equals negative 3. Well, I know negative 3 is going to be greater than negative 5. But 2 is not less than negative 3. So this right here would be a counterexample. This will be one example where the sum of a number is not greater than both numbers. Last one, the value of x squared is always greater than x. Okay, well, let's think of some example. So let's say x is 2. Well, this is what it's saying. X squared is greater than, I don't know why it's doing that. It's greater than x. x2 is greater than x. Well, let's say x is 2, so that means x squared is going to have to be 4. 4 is greater than 2. Well, that's true. Okay? Now, and I can do 3, which gives me 9. 9 is greater than 3. 4 squared is 16. 16 is greater than 4. But what if we try, and we can even try negative numbers, like x equals negative 3, x squared, for this case, it's going to be positive 9. Well, 9 is greater than negative 3. But what about fractions, though? What if we even do a fraction? So let's say x equals 1/2. Well, x squared is basically 1/4. And 1/4 is not greater than a half. It's almost like telling me that 1/4 is more than 2/4. That's not true. So these are examples of counterexamples. You just have to have one example where it's not true. Okay? And that will give you a counterexample. So really the whole premise of this is that inductive reasoning is being able to look at patterns. It's being able to look at patterns and make a conjecture out of it, which basically, when it's a conjecture, it's just an unproven statement. Okay? Now, you can make a counterexample for those cases. Okay? And a counterexample will basically ruin the entire statement in itself. And remember, you just have to have one counterexample. Okay? So just remember, inductive reasoning is looking for is being able to find the pattern and continuing it and make a statement about it that hasn't been proven. Thank you and have a good day.